Welcome everybody, it's Tutor Justin, and this YouTube channel we're talking about here is how AI can help you study, help you just get in this educational space. More specifically, we're going to be looking at ChatGPT. There are a bunch of GPTs in the paid version, the free version. The last few videos we've done are all dealing with the paid version. The Math AI, the Tutor Me, the ChatGPT 4, and this video itself, we're going to do just the free version, ChatGPT 3.5, and we're going to see how well it does with this specific problem of rational functions. We're doing rational functions today, and see what limitations do you need to do the paid version? How does it differ? How does it help? And how it can really specifically apply to these rational functions. So some things that I have learned so far about using AI in this educational space is a lot of the olds don't really like it. A lot of the olds don't really embrace it. There's this mentality of, you need a, that's just cutting corners. And I look at it and just think that's wild to me because uh, the same thing was probably happening during the Industrial Revolution when Henry Ford created the assembly line, or when Google was invented and you're searching things on the internet. It was Google search. Googling is now a verb, not a noun of a company. Hey, did you Google that answer? All of these different steps in this evolution of technology, have they taken away certain jobs? Yes, nobody really goes to the library anymore, unfortunately. Nobody really goes in the library. There's now robots in a lot of manufacturing facilities. And this right here is just one next step in this technology revolution or technology evolution. I look at this is just another industrial revolution. In this case, looking at AI, and I was nervous about it because look, I tutor students, and can it replace me for 80% of you? It can, and that fucking stinks. But instead of trying to complain or do anything, or instead of just complaining about it, well, I might as well become an expert, and that's what I've done. I've tutored here for 12 years. I paid my way through undergrad. I paid my way through grad school tutoring, and this is one tool that I've used for the last year on all of my tutoring sessions, prepping, during, post, anything that deals with tutoring. I've put all sorts of problems through ChatGPT just to see what it can do. And these series of events that we're doing, these series of videos that we're doing here at Tutor Justin, is just showing different ways on how to use ChatGPT on certain mathematical topics. We're going to do statistical topics, we'll do physics, we'll do biology, any type of any field really in this educational space. And if you have one that we really want to do, go ahead, drop a comment down below. Do the whole like and subscribe to the channel too. Why not? That would be awesome. Um, so in that case, we're just gonna start here with these practice problems. I think there's about 5 of them we'll talk about with the rational functions and how, just again, the free version um, deals with handling these functions, because there are some good things about it, but there are also some bad things that I've found. All right, so here we go. Okay, so here we go. These are just a set of practice problems here on the right hand side of rational functions that I put together. These are typical problems you'll see in a college level course. We're going to try to find vertical and horizontal asymptotes. We're going to simplify rational expressions and finding domains. All good things that can be, there's different rules that go with it. There's little nuances that you got to remember. So let's see how well ChatGPT does by solving these problems. How can it teach you how to do some things? Again, we're going to be using the paid or the free version, the 3.5. So the first question: determine the vertical and horizontal asymptotes of a function. One thing I can never remember what the rules are. So what are the rules for a for finding horizontal and vertical asymptotes? Good thing for a good old autocorrect. I can't remember. One thing that is crazy about ChatGPT 3.5, it is extremely fast. It is a lot faster than any of the GPTs that we've talked about before, Math AI, Tutor Me, ChatGPT 4.0. It is really fast. The accuracy there, you'll see, is it good? How difficult is it to really, get the knowledge that you want to? Very difficult of checking answers. And I always find that portion the best portion between checking answers and finding practice problems. Those are the two best things that ChatGPT can do, and it doesn't do one of them. So that's why I do think the paid version, paying for that is slightly better because you only need it for just during the semester, and then you can pause it and then redo it after. And the cost of it, even if you did a whole year, 100 or two times 24 is $240 a year. That is still cheaper than a tutor. And it's there 24/7, 365. So that's just my little rant here. So let's look at this. Horizontal asymptotes. Okay, degree of the numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. So limits at infinity. Talks about that. Vertical asymptotes. Vertical asymptotes occur when the function is undefined. Okay, find the values of x when the denominator of the function equals 0. Excellent. So if we look at number 1, when does x squared minus 4x plus 4 equals 0, right? So that's just the quadratic equation. So let's look through these. Oh, it even provided an example. Well, that's good. Consider the function 3x squared minus 2x plus 1 divided by x minus 2. So we know that based off of that definition, the horizontal or the vertical asymptote is when the denominator equals 0. So that's when x minus 2 equals 0. So that's when x equals 2. Excellent. So we got the horizontal. The degree in the numerator is equal to the degree in the denominator. Therefore, the horizontal asymptote is the ratio of the leading coefficients, which is y equals 3 over 1, which equals 3. That is just not true, right? This is where it can get messy. Based off of the degree of the numerator is less than the degree of the denominator, the horizontal asymptote. So, but the degree of the numerator is more, and just the one in our practice one, it's the same, right? So therefore, it's 2 over 1, and it would just be 2, right? But in the example they gave us, it's definitely incorrect. So the example, now let's just say, I'd be confused too. The example you provided has a leading power of 2 on the numerator, or in the numerator, and 1 in the denominator. Let's just ask again, what are the horizontal asymptotes? Difficult to spell. So apologies for the confusion. Let's correct that. The degree of the numerator is 2. Okay, so there is something that you have to be aware of, and that's why you just can't take it for gospel, right? You having no foundation is difficult. difficult for ChatGPT or for you to learn from ChatGPT, you got to have somewhat of a foundation like we read, but you got to be able to do a little bit of critical thinking. We read the rules and it didn't even follow the rules. We ask it, it corrects it. The more you correct it, the better it'll be in the long run. That is the hope, or at least that's what Elon says. So using the polynomial division, we get 3x plus 4 plus 9 divided by 2 by x over 2. Okay. Which represents the slant asymptote. So the slant asymptote for the function. When the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, perfect. So there is no horizontal asymptote, but there is a slant one or an oblique. So if it asks you, some math classes ask you to do it. If not, you could just skip and just say there's no horizontal asymptote. And if there is, well, look, it showed you how to do it. The slant end asymptote describes the behavior of the function as x approaches positive or negative infinity. Cool, cool, cool. Perfect. So y equals 3x plus 4. Excellent. So now let's look at how it will correct. This is the hard part. We got to copy and paste. So this is where copy and pasting is a little difficult. So we have 2x squared. So the caret is always mean squared. Minus 8 divided by, and then parentheses, x squared minus 4x plus 4. And sometimes, that's why I always find it better to use a combination, or that's why the paid version, you can actually take a picture of it. So you can use a combination of your browser and your phone and take a picture of it on your phone and then upload it and reference, hey, practice problem number 1 is shown in my uploaded photo above. Can you walk me through how to find our vertical and horizontal asymptotes? Boom. And it does a fairly good job of reading. You might have to correct it here and there, but it does a fairly good job. And then here, boom, it talks about the horizontal and vertical asymptotes, 2x squared minus 8. Read it correctly. Based off of that, the degrees are equal, so it's 2 over 1, 2 vertical asymptotes. Factoring, you can check out our factoring video on showing how ChatGPT shows you how to factor and what it consists of and different quick ways of finding it. And it did a very good job talking about factoring. You can check out that video and our polynomial video. Cool. And does the vertical asymptote, x equals 2. Excellent. So it does a great job talking about it. Now let's move on to simplifying the rational expression. This is difficult. I always screwed up on these. I never remember the rules, so we can start by asking what the rules are. We can start by asking what the rules are. What are the rules for simplifying rational expressions? And it's going to go through and talk about it. And it'll go through and talk about it. Let's simplify rational. It gives us an example. Okay, so it talks about factor the numerator and denominator, cancel common factors, avoid division by 0. Again, we don't want to divide by 0. Remove negative exponents, simplify further if possible. Gives us an example, 6x squared minus 12x over 3x squared minus 9. Factor the numerator. It does, okay, that's pretty cool. It gives you an example of whatever you're talking about. Not all, gives you an example of the process. It gives you an example of the topic of whatever question you ask. The other GPTs don't always do that. So that's good that 3.5 does. It's very curious that the other ones don't. Sometimes it'll just give you, a definition of what it actually is. It's not giving you a example. So this intuitive one gives you an example, and the level of the example is great too. It's exactly the college level that it's on the same difficulty level as the practice problems we're providing. So factor numerator and denominator, 6x squared minus 12x equals 6. Yep, we just took out a 6 and we took out a 3. Cancel the common factors. Left with 2 on the top. Avoid division by 0. Ensure that x squared minus 3 doesn't equal 0. This implies that x cannot be rad 3 or negative rad 3. Okay, remove negative exponents. There aren't any. Simplify further if possible. So the simplified version is just 2x minus 2, x squared minus 3. Perfect. The hard part about simplifying the expression is, how do you know when to stop? I know in a lot of people that I've tutored, that's the number one question they ask. So let's see what ChatGPT says. How do I know when the expression is simplified to the smallest point? So knowing when a rational expression is simplified to its smallest point involves ensuring that no further cancellation of common factors. So the big thing, it talks about common factors, which is true. It's exactly what I would say. Can be made in the numerator and the denominator. No common factors, no more factorization. So the quadratic formula, check for excluded values, ensure that there are no values of the variable that would result in division by 0. Good. Check for negative exponents compared to original 4. As clear and concise as possible. And so what it's saying is you just got to ask yourself, are there any common factors? Go through this checklist. That's all it's asking. I would have said the same thing. And then I would also add that repetition. Unfortunately, repetition is the key here. So now let's look at, how does it solve ours here? X cubed minus 2x squared minus x plus 2 divided by x squared minus 3x plus 2. Don't forget the parentheses when you do it. I really hope at some point they do some type of math input keyboard on there. That would be awesome and save a lot of time. So I didn't even have to simplify the expression. That's pretty cool. Sometimes it'll just ask you. I know other GPTs will just ask you, what do you want me to do with this? And this already knew. We're going to simplify it. Factor numerator and denominator. Factor both the numerator and the denominator. Went through the checklist again. Excellent. And then now after it went through the rules one more time, and then it applied the rules to there. That's a great way. Again, this is you learning. This is a great learning tool. This isn't, hey, just check my answers. Is it correct? That's not the point of this. This is so you can, if you take, 30 minutes out of your day and practice your homework a little bit on any subject, really, that would result in a better score. Go out an hour later, instead of going out in 10, go out at 11. Take that hour. Watch 1 or 2 less TV shows, depending on how it is, or depending on how long each episode is. So those are just little ways that you can just cut time and utilize that for studying purposes. And in this case, we did it, factored it out completely. The simplified version is itself no further simplification is possible. All right. So it can't factor. So it can't go any further. It does not factor easily for simple factorization. And unfortunately, hopefully, the hard part is, let's see, how can we know how Yeah, how can we know that the numerator or an expression to the third power can't factor easily? How does it know? Determine, because how can you, it's difficult when the bottom one, easy, right? X squared minus 3x plus 2. You guys have been factoring for days to know that it's x minus 2, x minus 1, right? But the power of 3 has always been tricky. So this is the rational root theorem, just like we talked about the polynomials, talked about the rational root theorem, grouping, special factoring techniques, trial and error. That's a big one. Computer software. So hopefully if somebody, professor gives you that type, it's not a super difficult one. And if he is, he's just trying to be a dick. And I don't, it's like, let's know the process. As long as you know the process, you'll be all right. All right, now the last one, determine the domain of a function. Okay, so let's go. How do we, oh, thank you. I haven't been being nice. Thank you. Always be nice to your robot, because you never know if they take over. They're gonna come to you and be like, oh, thank you. We're not gonna kill you. Okay, that's good. So always be nice. Say please and thank you. Can we please move on to how to find a domain and proper domain notation for rational expressions? All right. Yes, again, remember, please and thank you. All right, so steps to finding the domain. It just flies through it. Identify excluded values, find any values of result, and division by 0 in the denominator. Again, just like we talked about with the horizontal asymptotes, denominator equals 0. Boom, excluded values. Obviously, write domain in proper notation. Okay. To express the domain in proper notation, such as interval notation or set notation. Most of the time it's interval notation. So let's go, yeah, it says it here. Consider the expression 1 divided by x squared minus 4. Denominator equals 0. Squared equals 4. Oh, excellent. So it talks about that. Exclude the values 2 and negative 2 from the domain. And that's it. Everything else, it's the only rule. Domain equals 0. Or one of the big rules, did it ask? Okay, so let's say okay, so it talks about expressions defined under that. We have a square root in the denominator. I know that's something, obviously. So the big question is, what are the excluded value rules besides when the denominator equals 0? Let's see what it says. Besides division, there are certain situations, man, it is just flying. Square roots, boom, for each real value. Remember, we don't do complex numbers, so when the square root equals, when the cube root, or when the square root is negative, can't have that. Even roots of negative numbers for even roots must be non-negative. Logs, only on real numbers. Positive, can't take a log of a negative. Inverse trigonometry, fraction of a root, domain restrictions from problem context. So if you're talking about manufacturing, you're probably not going to have a negative quantity, so it could probably be positive. Real world constraints a lot of times when it's negative. So let's look at what is the domain for, and then we have x minus 1 divided by square root sign, right? Here it is. Just like in Excel, we just write square root. We're going to put open parentheses and then x squared minus 3x plus 2. Let's see if that works. To find the domain, and it wrote it exactly Correct. The division by 0, we must ensure that the expression under the square root is non-negative. The square root function, the argument of the square root must be non-negative. So the inside must be non-negative. So x squared minus 3x plus 2 is greater than 0. And then it goes to the inequalities. Good. So x equals 1, x equals 2. So to test each, and then it testing x1, test 1, test x. So this interval is positive, so this interval is negative, and this interval is positive. Does the testing. Excellent. Determine the domain. So the domain, so can you go over testing the intervals? Let's see if it talks about it. Test by step. Identify the critical points. Critical points are the values of x when the expression under the square root changes sign. In this case, our critical points are where the expression equals 0, okay, which are x equals 1 and x equals 2. The partition, the real number line, into intervals using the critical points. The critical points, divide the real numbers into 3 intervals. Yep, because it's got to be, so we got to see if between 1 and 2, okay? Because it's a square root sign, between those, it's either going to be a positive or negative. It's either going to stay negative or stay positive. So those critical points or those junctions when they equal 0, it's what it's trying to say is that's when it flips. That's when there's like more or less an inflection point. Talks about the test and then does the example. So 0 minus 1 times 0 minus 2. So this expression is positive. X equals 3 halves, x equals 3. And they use hard numbers to test things in between, right? So in between 1 and negative 1 and 2. Perfect. All right, excellent. And that's how it does. It does a pretty good job. And if again, the good thing about it is you can ask questions. If you don't understand things, like all the questions that I ask it are typical questions that I get asked when we're doing this subject matter. So it's okay. And one thing that's great about using ChatGPT, if you really don't understand it, no judgment. It just it just spits it out for you. It just it's not, there's no judgment there. It just tries to make sure to answer all of your questions. I know sometimes it can be intimidating when you're halfway through a semester and you just don't understand like the first thing that was in the semester and then you think it's too long. I don't judge, either does ChatGPT. Thank you all for watching this video. If you have any topics or anything you'd like me to cover and see how ChatGPT or different AI source, Copilot or the Gemini or anything that you would like me to cover with AI, just go ahead and comment down below or hit me up on Twitter or X at the Tutor Justin. So I hope you guys enjoyed the video and we'll see you next time.